Good afternoon. Today we're discussing the SI measurement system. The SI system, the metric system, the International System of Units, is a system of units of measurement consisting of 7 base units, mostly widely used system of measurement. The United States is the only industrialized country that has not adopted the SI system. Some things that you need to make sure you get down in your notes down here is meter is the base unit for length. Kilogram is the base unit for mass. This is always surprising to students. Seconds is for time. There is no difference between the standard system and the metric system when it comes to time. Those right there are the main three things that we'll deal with here in ICP, but we have the meter is what we use for length. The kilogram is what we use for mass, not gram. Typically we report things in kilograms, and seconds for time. Okay, a lot of times what we'll discuss is converting within the metric system, and this right here is pretty much as far as you could ever possibly talk about in most of your science classes, and probably as high as you could ever talk about in form of your science classes. I'm going to put a little chart up here at the top, and I want you guys to copy this down. Okay, up here now, I've got a little chart here for the metric system. I would put this on the inside cover of your notebook, put it maybe in that front slip of your overall portfolio for this class, but you're going to use this quite a bit in here. Some rules for recording measurements. Measurements must always include units. Must always include units. Always errors in measurements. Measurements are the best estimate of a quantity. A measurement is only good if you know that it is reasonably close to the actual quantity. It is important to indicate the accuracy and precision of your measurements, and scientists and engineers use significant digits to make the accuracy and precision of measurements clear. Precision and accuracy. Precision is repeatability. Accuracy is the degree of closeness of measurement of quantity to the actual or accepted value. For example, down here, this person shooting would have high accuracy but low precision because the bullets aren't close to each other. This person has high precision because the bullets are all close to each other, but he has very low accuracy. Here's an example of high accuracy and high precision. All right, so precision is repeatability. All right, repeatability. Someone who shoots free throws and always hits the front end of the hoop, they're very precise. Someone who is all around the hoop and keeps hitting all the different sides of the hoop, they're not very precise, but they're very accurate. Okay, recording measurements. Some general rules that we have. Digital instruments read and record all the numbers, including zeros after the decimal point, exactly as displayed. All right. Digital instruments, exactly as displayed. A decimal scaled instrument, record all the digits that you can certainly determine from the scale marking and estimate one more digit. So this is going to be, for example, on your ruler. All right. Fractional scaled instruments, they need special consideration. We'll talk about those later. But this one right here, decimal scaled instruments. Let's talk more about this. We're going to estimate one more digit. All right, the metric scale. A typical metric scale often includes a 30 plus centimeter graduated scale. Each centimeter is graduated into 10 millimeters. So, there, each of these are centimeters. All right, and this right here is just a typical ruler that you would have in class. I've got 30, 40 of them up here, the big ones. Notice it goes up to 30 centimeters. Each of these little lines right here, those are each called millimeters. And there are 10 millimeters in between every centimeter. So what we've done here now is we've really blown this up. This is 1 centimeter. And there are 10 of these as you count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th one, it's 10 millimeters, or it's 1.0 centimeters. And again, that's what I want to show you here. 1 centimeter equals 10 millimeters. Okay, on here, we've got this rectangle that we're trying to measure here. And this is kind of a smaller view. Let's blow it up here and see what we find. Well, it goes past the 3 centimeter mark. It's not quite to the 4 centimeter mark. So each of these are what? Well, they are millimeters. So it's 3.1, 2, 3, 4, 5, 6, 7, 8, 9. It's between 8 and 9. So it's between 3.8 and 3.9 centimeters. So how do we estimate? Remember, we're supposed to be making those estimates. We would say it's 3.85 centimeters approximately. Here, they've estimated it to be 3.84. Right, what I want you to understand is as long as you're trying to estimate it, you're doing a great job. Remember the general rule, all right? Decimal scaled instruments, we want to record all the digits that you certainly determine from the scale markings and then estimate one more digit. So that's why we had to make that estimate right there. All right, let's take a little time here. I want you to go through here and find each of these measurements. Remember, you're going to estimate one more digit than what you can actually see. Do your best job. Some of them you won't be able to, some of them it's not going to be very easy. Some of them it's going to be pretty easy. But you should be going to 2 decimal places on each one of these. So go ahead and pause it, and when you come back, I'll have the video for you. Pause. Well, I went through here and put them all in here. Hopefully then, your guys's are close to this. You might have, for example, you might have 7.31. That's still really, really close to 7.29. I'm not saying mine are exactly correct. I'm just saying mine are really, really close to what it's supposed to be. Well, hopefully that was interesting there for you two guys today. And I'll catch you guys on the flip side.